thank you for having come in such numbers for this FIRA's third edition. Thank you for following us live on our FIRA's YouTube channel. We will have, you'll see, a very full day with speakers coming from all over the world. We're very proud of that. That is to say, speakers from Australia, Japan, Germany, England, United States, Italy, and even from Toulouse. So, thank you, everyone. And please welcome on scene for a short introduction one of the two men who imagined and launched the FIRA 3 years ago, Naïo Technologies co-founder and CEO, Aymeric Barthes.
Good morning, ladies and gentlemen. I'm very glad to introduce this third edition of FIRA with an incredible schedule of great speakers that will be concluded by an intervention of Food and Agriculture Organization of the United States, of the United Nations, sorry. I think there is a critical and mandatory question to answer. That is, how to produce enough food to feed the world. And this question has to be completed. How to do it sustainably. Agriculture is at a tipping point. Farmers need new solutions to face new contexts, environmental, labor, and increase of world population. It is not the first time that this kind of context change happens. In 1960, tractor became a standard in agriculture to answer the problem of food production. But it took decades because there had to be change in practices, specifications, and habits. Probably in 1950, buying a tractor was madness. Today, not buying a tractor is unthinkable. The invention of tractors in agriculture has allowed to produce more food, to change the life of consumers, and to reduce the hard work for farmers. It was a revolution. Today, it seems that we are at the limit of this model of having a driver in a tractor. It is also becoming more and more difficult to produce enough food without endangering Earth and increasing the pain for farmers. It is time to change, to think different, to propose a new solution, a new revolution. It is time to precision agriculture and robotics. Robotics has to prove its value, as tractor did in the past. It is a long and hard way, but that is the challenge that we have chosen to take up. All of us in this place, at this third edition of FIRA, we are pioneers. Welcome to the FIRA 2018. Thank you.
Thank you, Aymeric. Now, I'd like to call on scene Mr. Marc Vanacht. Marc Vanacht from Ag Business Consultants. Yes, you can. Good morning, Marc. I think you're proposing us a quick overview of agriculture robotics.
Thank you, yes. This was a joyful but painful preparation for this conference, because every week I had to change my presentation because new robots came on the scene. And since I've made this presentation and delivered it to the organizers a week ago, 3 new projects have popped out. So it's a very dynamic environment. Our goal is to have convenient, low-cost mobility and traceability from the field to the market, right? And sometimes the solutions are much more simple than we imagine. And so she's mobile, she uses a robot, and she goes directly from the field to the market. A couple of precautions. I do not know everything about robots in agriculture. Even if I did, there's a lot I couldn't share because of confidentiality agreements. Most omissions are not deliberate, some are. And this presentation is already obsolete. Like I told you, there have been 3 new projects since this presentation was made. So let's go and position robots in the broader field of agricultural technology. And so I look at agricultural technology for crops going from resources on upstream over production at the farm to downstream. And we have, for example, changes in the upstream marketplaces. There are social networks that are working. And in the downstream marketplaces, the requirements and the demands of the consumer are imposing changes. On top of that, new crops are being developed, and new types of farms are being developed, and some of these farms are not even in the rural areas. Some of them are in old warehouses in the city. All of this is AgTech. Part of AgTech is also DNA-based biotechnology that we put in seeds that can be breeding traits, the editing, etc. But there's also the organism-based biotechs that uses viruses and fungi and yeasts to create new products for plant protection. That's AgTech. AgTech is also the software that allows the farmer to manage their finances, and software and databases that give a broader view to the farmers about the weather, the soil types, what are the choices of fertility, and so on, growth models. So all that then, all those databases and all that software can flee into traceability systems that then connect to the consumer. So this is how these things hang together. Now, there's the whole area of sensors for weeds, for diseases. There are the sensor platforms onto which the sensors are mounted and that then fly or crawl or move. All that is then enabling an improvement in precision agriculture that largely is a more precise, more timely, more variable application of inputs. The different systems, the equipment in the field is connected with telematics to the manufacturer and to the farm, and so on. And so that precision agriculture then ties back to the databases that allow to make the decision. So you've seen all the aspects of precision of AgTech, and I haven't mentioned the word robots, because robots come in now. Robots are gradually taking over or improving or simplifying some of the operations we already were trying to do in a precision agriculture mode. So let's go back and fill it all together. This is how the global image of AgTech looks like, and this is where robots belong. So let's go to robots in agriculture. I will mention many robots. So the presentation has 60 names that I will mention, and like I told you, there are now 63 projects I'm aware of. Robots solve widely different problems. There are robots in every stage of commercial development. There are robots of every size and shape, as you have seen in the exhibition hall. R&D for robots is funded through many different setups, and universities drive a lot of the innovation. So I will go into detail on each one of those. First, a question. If drones that are used for spraying or for observation, if we define them as flying robots, and actually most of those drones can fly independently. It's only for legal reasons that there has to be a pilot on the ground to control them. But if we take drones as flying robots, then there are 4 dominating companies in the world. DJI in China, Parrot in France, Yamaha and Yanmar in Japan. And they have sold many, many machines. For pesticide spray, there are now over 10,000 machines active in China and 2,500 in Japan. For scouting and sensing of crops, probably tens of thousands. And then for other professional users, hundreds of thousands. And as toys or for fun things, millions. So if we accept the definition of a drone as a robot, then there are already millions of robots available in the world. There. Here is the list, and you will read for yourself if you can read very fast, but this is the list as of a week ago. And so on the right is the code of the type of activity or the type of function that the robot has. Now, if you don't recognize your name on this list, I'm sorry. Go back to the second slide where I say why. Now, and if you see your name on the list and it shouldn't be, please tell me. Okay. Robots solve different problems. I've tried to break it down in platforms, scouting, weeding, chemical applications, harvesting, and then broader platforms. You clearly see that flexible platforms for ground operations and utilities with 13 projects are important. Scouting, 13 projects. Mechanical weed control, 9 projects, amongst which 4 are handled by Naïo. Selective chemical applications, 8 projects. Harvesting is 1 in large fruit, couple in small fruit, several in vegetables. So you see, there are groups of functions that attract more project work than others. Here is kind of from left the early development and right fully commercial products. Here you see where each or where many of the projects I mentioned above positioned. So you have some that are fully commercial, like the drones of DJI, also of Naïo, some of the parrots, the Armax and the Yanmar Heli. They're fully commercial. In early commercialization, you have Agrobold in Chile, Cerescon in Holland, Dino from Naïo, Gus and Jav in California and in Brazil. So a lot going on. More early, you still have a lot of work that's going on at Digital Farmhand, Washington State, Harper Adams University, etc., Totori University in Japan. So it spans everything. So from really commercial products to products that will probably take 3, 4, 5 more years to be developed, and everything in between. Another way of looking at things is that robots can be small, less than 10 kilo, and they can be giants over a ton. And so you can see, for example, that the Gus and the Javs and the Swamp Farms and the very heavy machines, and on the other hand, you have drones that you can hold in your hand, and everything in between. Again, wide variety, wide different approaches. Who pays? On the right, you see some projects that are funded by corporate entities. Agrobold in Chile by Engie, Blue River since 2018 in the hands of Deere, Bonirop, Bosch, Cerescon, a private company. There's the GGI, JAF from Jacto, the Yamaha and the Yanmars. But then some are in the hands of venture firms, venture capital firms, like Blue River up to 2017, FarmWise, Parrot Precision Hack. And then you have what I would call the consortium partnerships, where it's still largely driven by science universities, but where there is a certain level of private funding as well. When I started to put these things on this chart, I had no preconceived idea of who is funding. But what this chart illustrates is that most of the funding for robots in agriculture still comes from government and universities, and that on the other hand, large corporations have started to get involved. What I see on this chart is that the traditional American model of venture capital that fits very well social media, that fits very well other elements, that venture capital money apparently either hasn't understood yet how important agricultural robotics are, or they don't feel comfortable with it in the sense that they don't understand the technology, they don't know how to make money out of it. This is very illustrative, this is an interesting chart to see that. And if the people of the venture funds here in the room, you can talk to me any time of the day and tomorrow. Here is a list of universities that I've inventoried that have or are very active in the development of robots, and each one of them has, let's say, have come with robots that are very close to or are at the point of commercialization. And they come from, maybe for most of the people in the world, from surprising angles. Who would have known that Valencia, known for its citrus, is working on a robot for vines? Who would have known that Eindhoven, which is the capital of Philips, does asparagus harvesting? Who would have known that Polytechnique de Lausanne is working on a solar-powered selective sprayer? Here are some important people. And on some of them you will recognize, no, never mind. You'll see me somewhere. This is the academics in China working on robotics. And they had a meeting in July 2018 where we all came together. And there were some people from abroad that were invited to give talks. This is less than half of the people in China working on robots, because the other half works at the National Engineering Research Center for Information Technology in Agriculture, NERCITA. So you double this and add a bit more. That is the people in China working on robots. And I have not mentioned any robot from China. There's much more going on in China than I can show you or that I'm willing to show. Conclusions. Robots solve widely different problems. They arrived yesterday, some are launched today, and now some will arrive in the near future. Robots have many sizes, shapes, and forms. Some are discrete components or are invisible. Many come from different sources and setup. And yes, this presentation is already obsolete. Merci bien. Vielen Dank. Muchas gracias.